My dear students, welcome to a new science session. Today we are going to complete what we have started in the last session. We have learned in the previous video that there are 2 points of view to classify the types of waves. According to the direction of vibration of medium particles relative to the direction of propagation. We knew the difference between transverse waves and longitudinal waves, and today we are going to differentiate between electromagnetic waves and mechanical waves according to the ability to propagate and transfer energy. Let's start with the mechanical waves, which are governed by Newton's law. Mechanical waves, they are waves which need a medium to propagate, where they do not propagate through vacuum. Mechanical waves can transfer through solids, liquids, and gases. There are a lot of examples of mechanical waves like water waves, sound waves, and seismic waves. On the other hand, we have electromagnetic waves. Electromagnetic waves, they are waves which do not need a medium to propagate, where they propagate through vacuum. They propagate through solids, liquids, gases, and vacuum. And there are a lot of examples, but before that, we have to know that the speed of electromagnetic waves equal 3 times 10 power 8 meter per second. Examples of electromagnetic waves are light waves, ultraviolet light waves, radio waves, microwaves, and finally X-rays. Now let me ask you a question. Give reason. Hearing thunder after seeing lightning, although they both happen at the same time. Because the light of lightning is from electromagnetic waves, while the sound of thunder is mechanical waves, where the velocity of electromagnetic waves is much greater than the velocity of mechanical waves. Now, let's talk about some concepts related to wave motion and its properties. Number 1, wavelength. Number 2, wave amplitude. Number 3, wave velocity. And finally, number 4, wave frequency. So, let's discover each one of them in the following slides. Now let's start with number 1, wavelength. Wavelength of the transverse wave is the distance between two successive crests or troughs. The wavelength of the longitudinal waves is the distance between the centers of two successive compressions or rarefactions. The sample of wavelength is lambda, and the measuring unit of wavelength is meter. Wavelength equal the distance covered by waves over number of waves. Now let's discover number 2, wave amplitude. Amplitude is the maximum displacement achieved by the medium particles away from their rest positions. And you can discover that in the following example. Here, amplitude is the maximum displacement achieved by water particles away from its rest position or its calm sea level. The question is, how can you determine the wave amplitude? Well, you can determine the wave amplitude through the following law. Wave amplitude equals the vertical distance between the crest and trough of a wave over 2. Number 3, wave velocity. It's the distance discovered by the wave in 1 second. And the law of wave velocity is wave velocity equals distance covered by the wave in meters over time in seconds. Now, we have to learn different sound speeds through different media. The velocity of sound waves through air equals 340 meter per second. The velocity of sound waves through water equal 1500 meter per second, and finally the velocity of sound waves through wood equals 850 meter per second. Now let's start with frequency. Number 1. Frequency is the number of complete waves produced from the source in one second. Distance between two successive crests or troughs. Frequency, the wavelength, can be determined signal waves. The following is the distance between the centers of two successive number of complete waves over time in seconds. The sample of wavelength is the sample of frequency is f, and the measurement unit of frequency is hertz. As I told you in the previous lesson, oscillatory motion, we can say that here too. Periodic time t equal 1 over frequency f, and we have the last law of this lesson, law of wave propagation. Wave velocity v equals frequency f times wavelength lambda. My dear students, thank you for good listening. This video is created by Mr. Mohamed Hamdy, science teacher at Mansoura Royal Schools.